Welcome to Statistics, Unit 8. Today we're doing Lesson 4 on histograms. Your objective is to make a histogram and to use a histogram to analyze data. And your essential question is, how can you use intervals, tables, and graphs to organize data? Histograms are very similar to bar graphs. They are a little different in that histograms show intervals or ranges for their x-axis, and the bars are touching, and they are similar to dot plots in that they show the same shape and spread. And also histograms, the y-axis represents the frequency, that's the vertical, and they are also in intervals. An example of why you'd want to use a histogram is for anything that you have a data range, such as like ages or years, like decades. So here we have a histogram, and it's based on data from the National ACT exam, which is an exam that you may take when you're in high school. It's just like the SAT. It's an entrance exam into college. So when I'm looking at my histogram, first thing I notice is that it makes a nice bell-shaped curve, and it's symmetric. It's asking me to find the scores, or how many scores are included in the data set. In order to know that, the frequency tells me that information. So I can look at the height of each of my bars. And if you notice, they have little marks right here because they are intervals, but you can see the little tag marks so I can get that data. So those are the numbers that represent the height. So I can add those up, and when I add them up, I get 100. And I'm just going to list them on the side here. All right, our next question is asking us to find the range of scores that represent 17%. So I'm going to bring over my data from the other slide, and I can easily calculate the percentage. Remember that this is like if we're looking at 1 through 5, my interval, the 1 represent my part, my whole is 100. So a fraction is a ratio that makes a part to whole. So I can calculate all of my data points by taking their parts and dividing. What's nice about 100 is anything over 100 becomes that percentage. So 28 over 100 is 28%. So there's really not a lot of math. I don't have to do math. I know that that's 1% looking at it. But it's nice to just practice it until you get familiar with that strategy of dividing our ratios. So now that I have that information, I can see that the interval 11 through 15, this interval here, represents 17% of the ACT scores. What percentage of scores are included in the 21 to 25 range? Well, let's pull over our data from the other side, and we're looking for 21 through 25, which is this one here. So that would be 28%. So let's pull over our data. What two ACT score ranges make up more than 60% of the sample? When I'm looking at my data. I'm going to start with the big ones, 34 and 28. And when I add those up, that becomes greater than 60. So the ACT score ranges are 16 to 20 and 21 and 25. How do the numbers of the scores between the intervals 11 and 15 compare to the number of scores between the interval of 26 and 30? So we can look right on our graph and see those two. And I also have it written on our little cheat sheet here. And I can see that there is one more score in 11 through 15 range than the 26 through 30 range. So now looking at our histogram, we're going to come up with 3 statements about the graph that are true and one is going to be false. And again, there are a variety, and this is just an example. One true could be the number of scores between the interval 1 and 5 and 26 and 30 are equal to the number of scores between the range of 11 and 15. And if I take those two scores and add them up, it would equal the same one. I could also say that would be true. The number of scores between 16 and 20 range is double that of the 11 through 15 range. Why don't you see if you can come up with a different true statement that you can share in the discussion page. And then our false statement, an example could be that there are equal numbers of scores between 11 and 15 and 26 through 30 interval, and you can look on that graph and see that that is clearly not the case. See if you can come up with your own false statement and also share that in our discussion page. A local library surveys its patrons based on their ages. They created a histogram and we're going to answer some questions. First one says, determine the total number of library patrons. So in order to know how many people are in our sample, I'm going to look at my frequency, my y-axis, which is right here, and calculate the height of each of those bars. Once I do that, I can add them up. And when I do that, I get 50. So there's 50 patrons in all. How many of our library patrons are younger than 30? So I'm not including the interval with 30 in it. I'm looking at the interval of less than 30. And I can take those numbers, 8 and 15, and when I add them together, I get 23 patrons are younger than 30. Based on the information in the graph, which age range are 30% of the library's patrons? So I'm going to determine which interval is 30%. And I kind of can rule out a couple just based on size. So I know like this one's not going to be 30%. And these probably won't be 30%. So the way I'm going to figure that out, and so if I was really doing it, I wouldn't waste my time doing these three because I don't want to do extra math. However, for the purpose of the video and because technology is so nice, I'm going to go ahead and rewrite all of these as fractions. And since my total is 50, that is what I'm using. So I can't easily see, but I also know that 50 is half of 100. So I can kind of easily calculate some of these, but let's go ahead and do it. So remember, top number goes in the box. I'm doing part to whole. And when I do that, I get these decimals. So 8 divided by 50 gives me 16 hundredths. 15 divided by 50 gives me 3 tenths, and so forth. I'm looking for 30%, so I already know that this is my answer. Remember that 3 tenths over multiplied by 100 gives me 30. And just looking for my button to click. So I wrote out the math there. So 15 divided by 50 gives me 3 tenths. And when I multiply that by 100, I get 30%. So my interval is 20 through 29. We have a new histogram, distance running. We have the number of runners and the miles that they run. And we're being asked to see how many runners run between 3 and 4 9/10 of a mile each week. So I'm going to look at my intervals down here. And I have 3 to 3 9/10, and I want to go up to 4 9/10. So I'm going to include these two intervals. First thing I'm going to do is look at my little marks on the side and calculate how much each bar represents in my histogram. Now that I have that, I can say 8 plus 12, which is 20, so 20 runners. Using our same histogram and our data, we're being asked how many runners run less than 4 miles a week. So I'm looking at the data that includes everything that is less than 4. So I have 5 plus 5 plus 10 plus 8, which is going to give me 28 runners. Which of the following statements best represents the data above? I have 4 choices that deal with percents and fractions, so I'm going to go ahead and just do the math really quickly. When I add 5 plus 5 is 10, plus 10 is 20, plus 8 is 28, plus 12 is 40. So I'm going to set up my fractions, my part to whole. So 5 over 40, and I have 2 of them, simplifies to 1/8, which is 12 and 5/10%. I have 10 over 40, which simplifies to 1/4, or 25%. 8 over 40 simplifies to 1/5, or 20%. And 12/40 simplifies to 3/10, which is 30%. Looking at A, 25% of the runners surveyed run 4 and 4 9/10 of a mile each week. When I look at that, that one corresponds with this one, which is 30%. So that is incorrect. 1/3 of my runners surveyed run 2 and 9/10 of a mile each week. That one corresponds to this one here, which is 1/4. So that is incorrect. 1/5 of my runners run 3 and 3 9/10 miles each week, which corresponds to this one here. And yes, that is 1/5. So that is correct. And I'm not just going to rule out D without reading it. The number of runners surveyed who run less than 1 mile is equal to the number of runners who ran 3 and 3 9/10 miles each week. Well, when I look at the 3 9/10, that's not equal to anything else. So right there, I know that that is not true. It is comparing it to this one here, which is less than 1, and those numbers are not the same. So that is not correct. We have completed lesson for the first half on histograms. Our next lesson will be looking at stem and leaf plots, but please remember to complete your Khan Academy, your IXL practice, and your exit ticket before moving on. And if you have any questions, please send that to me in the discussion board.